This is part 2 of my little adventure where I develop, deploy and test little distributed application. Let me rewind where we stopped last time. This front-end app we have connected with the two web API services. First one responsible to deliver data got from the Redis cache or from the SQL database. When we need to mutate something, we have another one web API which records data to the RabbitMQ. Then we have another one worker service which has responsibility to process mutation messages like create, update or delete, together with another one worker service responsible for cache population, which reads data from a SQL and then pushes data to the Redis cache. Here this version deployed to Azure Kubernetes cluster. Let me warm it up and check configuration. So let's create some data. We can see its details. We also can delete. Okay, right now in the database we have 0 items and 2 messages recorded during the warm-up process. So let's test this composition with our Docker container for the performance test. During the test we execute get all items 10 times, and we also execute request to create one item. All of this is executed for exactly 1 minute, and then we check how many items we've been able to record while constantly reading data from the system. Let's wait for the result. Okay, during 1 minute we've been able to execute all tests successfully, and total amount of iterations is this, and total amount of requests during 1 minute is that. Pretty good result with a queue for mutations and constant data read operations from the cache. But what if there is a better way to do all of this? And as better way, I mean an actor Orleans framework provided by Microsoft, where all our operations could be executed by different actors, and then responsibility to deliver data and to create data and manipulate with external data services could be encoded in the side effects of the actor themselves. Okay, let's check what we have in the code. When we try to get data from our composition, we just need to ask specific actor to get us list of everything what it has collected, and then it's responsibility of the actor itself to store necessary amount of information. Here is my list items actor, and what it does, it has a queue with 10 items, and it has information how to get list and how to get data from other actors. And here, when we add to the queue or add new item to the list, we just take care that there is only necessary amount, and when we read data from the actor, we just provide its internal state. Right now our list actor saves its state in the Redis database. When we need to mutate some data, we have just different actors responsible for that. We have an item actor which saves its state into the Redis database, but also as a side effect updates SQL database. Let's check. This is create procedure of an actor. It saves itself into the Redis cache, then updates information about the list of available items, and finally saves additional information to the SQL database. The same for update, the same for delete. So what we need right now is to configure our composition to use this last data access strategy. It has its magic name. Let's make sure that we don't use any caches and nothing. Like that. The same for our data mutation. It doesn't need any caches. And just needs specific strategy. And we also don't need our processor completely, because it has nothing to do in this case. Okay. Now let's redeploy our composition to Azure. Our composition deployed successfully. Let's grab its URI. Now we need to verify our configuration. We don't use caches. We have 0 messages and we're not going to produce any messages, and we have 0 items in the database. So let's warm up our services by creating some test data. Like that, we have one item in the database. Let's remove it. Okay, nothing. Now it's time to grab our URI and start another one performance test session, this time with Orleans as our actors framework. Let's see how fast it is. Okay, performance test done. Let's record our results. Let's verify our application. Here is test data generated, and as soon as it's Orleans framework, we can grab its internals from the pretty good dashboard. So right now we have this amount of records in the database. Let's remove system grains. Okay, so we have one actor responsible for providing list of items, and we have this amount of actors. 5. Yeah, plus one test I've created during the warm up, responsible to store and to get data from the actors framework. Let's compare results. We have a little bit in total amount of requests and total amount of recorded data, but with actors framework it's much easier, and code we have much cleaner. We don't need to care about threading, queues and everything. Actors themselves handle all the strategies for data manipulation. Let's see how it goes.